Hello everyone, welcome back to lecture 25. So, we were discussing about the glacial lake outburst flood. So, this is the part 2 of this lecture. In the previous part, we have completed the glacial lakes, how it forms, what are the different types of glacial lakes, what are the different types of moraine dammed lake we have. So, now we will continue this discussion and we will see the details, how can we map the glacial lakes. So, we have satellite imagery, that is one of the source. Then we can also use digital elevation model, different indices can be used, classification techniques can be used, microwave remote sensing data can be used, because optical has some limitation at the high altitude where the cloud coverage are more consistent. Then multi-temporal change detection can be used to identify these or monitor these glacial lakes. Field investigation is the key of validating all these results. Then machine learning and deep learning approaches are now very popular and it can be used. And the GIS, basically where we can integrate all the data sets together and analyze the glacial lakes presence or their increase in the size. So, when we talk about the glacial lake mapping, so this is very generic flow chart which explains the generic methodology. So, here when we have the satellite images, it can be optical or microwave, and we have different types of methods. Particularly for optical, we have different indices. Then for microwave, backscattering thresholding method can be used to identify the glacial lake, right. And here the manual digitization is also an option, and we can also identify the glacial lake, or this can also be used to validate or to correct some of the lakes features which are coming from optical and microwave processing. And then these are used for glacial lake monitoring, and then temporal analysis of the glacial lake can be done. Mapping and monitoring of glacial lakes in India. The CWC, Central Water Commission, in collaboration with the National Remote Sensing Center NRSC of ISRO, is responsible for the routine mapping and monitoring of the glacial lake throughout the India. So, you can see the different glacial lakes have been continuously monitored, and the satellite derived long term change analysis provide valuable insight for understanding glacial lake dynamics and their potential to glough, right. So, here you can see in 1989, 1996, 2001 and how it is changing with time, right. Sisper Glacial Lake outburst flood from Karakoram 2022. So, here we have seen a major disaster which happened in 2022. The Karakoram Himalayas are vulnerable because of the changing climatic condition, and which are causing the catastrophic flood in the surrounding areas or particularly in the downstream. The increasing natural and anthropogenic activities, especially in the Indo-Gangetic plains at the southern flank of the towering. So, we have analyzed this Sisper lake breach which occurred on 7th May 2022 in details using satellite remote sensing data sets, right. So, here you can see different maps which is from that publication, right, how these lakes have been formed over the time and how they breached in 2022, right. So, the details are available in this particular paper. Now, the Imjatuso lake. So, here we have one lake from the Nepal. So, this lake is situated in the Mount Everest region at an altitude of 5010 MSL. Lake is fed by the glaciers. Its average highest altitude is 7590 meter. And this is the fastest growing lake in the Himalaya, and it is one of the potentially dangerous lake in the Nepal Himalayas. So, you can see the location is given. Then this is another example. So, this is a false color composite FCC that I hope you remember from the remote sensing portion. So this is captured by the LIS-4 MX sensor on board the ResourceSat-2 satellite on November 27, 2016. This is the mountainous terrain which labeled feature ridge and hill shadow that helps to illustrate the area relief, right. The glacier formation located in the Manas sub-basin which belongs to the broader Brahmaputra basin. The image clearly highlights the glacial lake positioned at the glacier snout. The lake is visible in the bright blue tone representing the presence of water. The glacier appears as a lighter textured. So, you can see here. You all must have heard about the South Lonag Glacial Lake. So, the South Lonag Glacial Lake has witnessed a substantial increase in the lake area over the time. So, this example I have already quoted in the previous few lectures in 1967 and 2022 how the area is changing, right. So, now let us talk about the identification and mapping of these glacial lakes. So, for the glacial lake mapping or identification, we know that these are located at the higher altitude. So, the satellite images are preferred, right. Let us try to understand the identification and mapping of glacial lakes. So, we all know these glacial lakes are situated or located at the higher altitude where field investigation is very difficult. That is why the satellite remote sensing data sets or the UAV based measurements are one of the important source of information. So, utilizing these satellite images or aerial images, we can have different types of indices that can be used to identify or to map the glacial lakes located at higher altitudes. So, let us talk about the GLOF risk factors. So, size of the glacier, melt rate, size of the glacial lakes, strength of moraines, these are the key parameters that may trigger the GLOF risk, right. The population along valley, infrastructure, livelihood, these are getting affected because of any such GLOF event. So, what to do? So, establish risk model, lake inventory should be there, field survey of the most at risk lakes, monitoring lake regularly, develop mitigation strategies for extreme condition, and we should have a early warning system for susceptible glacial lake which is located at the higher altitude. So, the glacier and glacial lakes are found in remote, difficult to reach areas, making field based inventories time consuming and difficult. Satellite imagery and aerial photos prove to be more efficient in the accurate mapping and monitoring of the glacial lakes. When we say regular monitoring of the glacier and glacial lake, it is remote sensing only which can help to map these on a regular basis by enabling the observation of lake dynamics, surface area change and surrounding terrain using satellite remote sensing, aerial photography and thermal sensor. So, all these can be a very good source of information. So, here we will have the steps involved in generating the inventory of glacial lakes in Himalayan region. So, first what we will do, we will go for the basin boundary delineation, then we will have the digital database, then we should have orthorectified satellite images and then identification and digitization of the glacial lakes. So, this will help you to have a very high precision digital database of the glacial lakes. I hope you have understood the basics of the glacial lakes, how they form, what are the different types of glacial lakes, what are the different types of glacial lake boundaries or moraine dammed lakes or ice dammed lake, different types, how and why we are giving importance to these glacial lakes, why these are important. So, that part we have already covered in the lecture, right. Now, let us try to understand what we mean by glacial lake outburst flood. and we will see the details on this. So, this particular video beautifully explains the GLOF, right. So, here this is one lake, right, and there is calving, and because of this calving you have release of the water. So, here the breach incision happened, right, and then this excess water will flow and it will cause the GLOF in the downstream, right. So, let us start with the basic. What is a GLOF? A glacial lake outburst flood or GLOF is sudden release of water from a lake fed by glacier melt that has formed at the side, in front, within, beneath or on the surface of the glacier. So, any kind of release of water from these lakes, that will be GLOF. A sudden release of melt water from a glacier or glacier dammed lakes, sometimes resulting in a catastrophic flood formed by melting of a channel or by subglacial volcanic activities, termed as GLOF. Glacier meltwater is often dammed by moraines, ice or bedrock, but its failure through breaching or overtopping can cause devastating impact on the mountain communities and infrastructure. So, I have covered all the different types and details why and how when we call it GLOF, right. So, any kind of release of the water which is excess in nature, which is causing the catastrophic impact in the downstream, that will be GLOF. In the Himalayas particularly, the melting of glacier leads to the creation of proglacial lakes. The expansion of these glacial lakes poses a significant risk of glacial lake outburst flood, a serious geomorphological hazard involving the sudden release of water from this glacial lake is called GLOF. GLOF is a specialized case, particularly here in this particular image you can see that it is a moraine dammed lake and it will breach and cause the catastrophic discharge water from the lake in the downstream. Generally there is two type of breach: overtopping breach, right, or the piping breach, and it will cause the rapid movement of the water, sediment and other mixture in the downstream area, leading to huge losses. So, it will carry everything whatever comes in the way, right. During the South Lona Glacial Lake outburst, it actually washed away 60-meter high dam, which was part of the Sikkim's largest hydropower project. So, the estimated loss you can see, it is huge. So, these lakes are located at higher altitude, but their catastrophic impacts can be seen in the downstream. So, why the GLOFs are important? I hope you have understood the basics. Threat to human settlement, destruction of infrastructure, evidence of climate change. This is one of the indicator. Economic disruption, environmental impact, and which calls for the early warning system. So, causes of glacial lake outburst flood. So, here you can see the glacier retreat because of the climate change, then glacial moraine failure because of overtopping or maybe calving effects, avalanches in that particular region, glacial lake overtopping, landslide, human activities, glacial lake expansion, glacial surging, earthquakes or any other seismic events, geothermal activities, extreme weather events like rainfall or snowfall, and the glacier calving. These are the causes of the glacial lake outburst flood. Why glacial lake outburst flood occur more frequently in the Himalayas? Because high glacial activities are there, glacier melting is more, it has increased, and which is also indicating the glacial lake formation. Avalanches are very common. Climate change is significant, steep terrain, the slope is very high, population density is also increasing, the landslide, earthquake, because these are the high seismic zone areas. The effects of GLOF can be seen as infrastructure loss, loss of life, agriculture damage, environmental damage, and this particular figure explains how devastating a GLOF can be, right. So, here you can see the breezes, this breeze, what has happened in this particular area. Now, we have understood what is GLOF and how devastating it could be, but how to mitigate, how to solve this problem. When you think about solving this GLOF problem, immediately one can say the reduce the water. How? It can be using the artificial drainages. Here high density polyethylene pipes can be used to reduce the water level. Early warning system should be established, so any such event will be forecasted and the people can save their life and property. The scientific approach is needed and the risk assessment should be done. Glacial lake cascade. So, the cascading lakes, an outburst flood from an upstream lake can overwhelm a downstream lake, right. So, we have seen another example where 3 lakes were connected. Now, here you see this is one lake, this is another lake, we have one small here, one here. Now, suppose this particular lake is very stable, it is safe, it is not vulnerable to glacial lake outburst, but because of some activity here, this glacial lake may release some amount of water, right, and this will enter here. This may also trigger these lakes or this will come to this, and then this lake will be vulnerable to glacial lake outburst flood. This is a Landsat image representing the lake cascading effects, right. Causes of triggering of GLOF events, the seismic activities, which is very important. Earthquake can destabilize the moraine dam directly or trigger landslide avalanche in the area. Heavy rainfall or rapid snow melt, that will also trigger. Volcanic or geothermal activity and ice avalanches, that will also increase the vulnerability of the glacial lake. Cascading events that we have understood in the previous slide. Human activities, activities like mining, construction, deforestation in high mountain areas can destabilize slope, increasing the risk of landslide or altering drainage pattern, potentially contributing to GLOF risk. So, the primary triggers for a GLOF is the collapse or breach of a moraine dam or ice dam water in a glacial lake. This is due to the glacier meltwater, avalanche or volcanic activities, and the causes the underlying factors leading to potentially unstable lake. The glacier melting and retreat, formation of unstable dams, ice, the dams formed by the glacier itself, increasing water volume in the glacial lakes. So, these will cause or trigger the GLOF. The dam failure, the moraine dam failure, ice dam failure. So, these dam failure mechanism have direct impact on the GLOF, right. Then displacement waves, the large waves generated by sudden event can overtop the dam, ice or snow avalanche falling into the lake, rockfalls or landslide entering the lake because the surrounding area can have the landslide event, large blocks of glacial ice calving into the lake. So, the Chamoli disaster was one of these example. The implications of GLOF, what can be the possible implications of the GLOF and what can be done to reduce the risk. So, different management techniques that can be basically reduce the risk. One thing we can do, we can reduce the lake level. If we lower the lake level, then the volume of the water is smaller or it will be less, and then it will reduce the vulnerability of that particular lake towards GLOF. The major GLOF occurrence in the India. So, this is a list. So, you can just go through it. You can see these are the glacial lake outburst event in India. Kedarnath disaster in 2013, we all know how devastating it was. Then South Lonak glacial lake, this is the impact you can see. Then let us understand the role of geospatial technology in GLOF study. The snow line in Himalayan glacier generally lies at an elevation of 3800 meters above mean sea level. Due to their remote and inaccessible location, studying glacial lakes through field investigation and inventories is very tough. Remote sensing and GIS is an effective tool which helps us to map and monitor these lakes. So, with remote sensing data sets, you can identify the surface feature, geometric properties, slope and elevation that can be identified, and the time series data will help you to study how a glacial lake is being formed and how they are changing their shape, size over the time. And the GIS will allow you to integrate all your satellite images, field investigation information into a particular model, and you can see how a particular lake is vulnerable to GLOF event. So, the space input is listed here, so you can read it. The volume and depth estimation of glacial lake, it is very important, right. So, in the absence of bathymetry data for a lake, an area based empirical scaling approach was adopted to estimate its volume. Various empirical models exist that approximate the volume of the glacial lake using their surface area. Among these, the equation proposed by Huggle et al. Is one of the most widely referenced and has been utilized in numerous prior studies related to GLOF studies, right. So, this is the equation you can see. For hydrodynamic modeling of glacial lake, these Huggle's equations are used to identify the volume of the lake. These models solve the basic flow equation, continuity, momentum, and mainly produces the outburst hydrograph due to dam breach, maximum flood level and discharge including time of travel at defined cross section. Glacial lake outburst flood have been simulated through a various analytical, numerical, empirical, parametric and physical modeling technique, highlighting the complexities involved in such event. These models are designed to represent impact wave generation, dam breach mechanism and propagation of flood water downstream. So, here you can see different models are available. To understand the flood propagation after breaching for estimating peak discharge, inundation boundary and time to peak and travel time is used. Modeling approach is very good for early warning system, mitigation planning and emergency responses. So, here you can see the GLOF modeling data requirement. So, this is a generic list. When you go for a specific glacial lake modeling, you will or you may require to modify this list. The structure geometry, boundary condition will be required in your GLOF modeling. This is one example. I am just showing you the example how it looks like when you have the GLOF modeling. So, this is just to see so that you will perceive what exactly I mean by GLOF modeling. So, because of the breaching, how the water is flowing and how much area will be covered during this peak flood time, right. Accordingly, we can have a mitigation policy. So, with this modeling you can have the depth map, you can have velocity map, at what location, what velocity we can expect because we have the topographic information. So, this kind of modeling will help us to save the lives and property. So, what are the final recommendation? Enhance the monitoring. Policy, we have to again adopt new policies, encourage coordination among scientific institutions, disaster management authorities and local government. Early warning systems should be there for any such potential glacial lakes which are susceptible to GLOF. Then future research suggest modeling potential breach scenarios and downstream impact mapping. So, these are the references which I have been referring in this lecture. So, you can go through it. If you are interested, you go in detail. Thank you very much.